Our goal today is the two objectives we want to cover. Is we want to be able to find determinants of 2x2 and 3x3 matrices, 2x2 and 3x3 square matrices, and we want to use Cramer's rule to solve systems of equations. As a kind of a sub-objective, we will also use determinants. We will also use determinants to find the area of a triangle, given just the coordinates of the triangle. Okay, so a determinant is basically a value of a square matrix. So you can only get determinants when you're dealing with square matrices. 2x2s, 3x3s, 4x4s, but we will not do 4x4s, we'll only do 2x2s and 3x3s. The way it would look if I ask you for the determinant, because it's like a specific question, it would either look like, it would say DET first and then have the matrix, in this case 6, 5, 8, 3, or it will have that symbol that looks like absolute values, but also has the rows and columns of a matrix. So either one, if I have it looked like either one of those two, I'm asking for the determinant. More than likely on the quiz I'll put DET of whatever. No, you have a quiz Friday and you will have a test on Wednesday probably. Alright, here's your general rule for finding your determinants. On a 2x2, all you do is if you have like say A, B, C, D, multiply the main diagonal, A times D, and then subtract that by the other diagonal, I call it the right diagonal, B times C. That's all it is. AD minus BC will give you the determinant. So looking at the example that we have right there, what's 6 times 3? 18. What's 5 times 8? And what's 18 minus 40? Okay, so negative 22 would have been the answer there. Just subtract.
So it's just like that.
That's 7, 5, 9, 2. Find that determinant. 5. And yeah, negative 31. A 3x3 matrix has a slightly different rule, and on page 272 they give you this graphic that shows you how you would get the determinant of a 3x3 matrix. And in actuality, the graphic looks harder than it really is, so don't worry too much. But it's there. Let's walk through an example, and don't worry about copying this. You know it's on page 272. Let's go through an example. I think that would be better. Yeah, that's where you find that graphic. Okay, so here's an example: 4, negative 2, 0, 3, negative 3, 10, 1, 2, 6, negative 1. Copy down that example, and then I'll show you what to do with the next step. First thing, recopy the first two columns. So that 4, negative 3, 2, negative 2, 10, 6, you need to rewrite those next to the matrix. Recopy the first two columns. Or rewrite. Okay, and then you're going to basically use that to help you get three, I like to call them left diagonals, the ones that go from the upper left to a lower right, so from left to right. So the first thing you're going to take is you're going to say like 4 times 10 times negative 1, you're going to have a negative 2 times 1 times 2, and a 0 times negative 3 times 6.
Okay. So you don't copy the last row?
No, you don't have to copy the last column, just the first two. That allows you to say, make sure that every number is going to be involved in this determinant, like gets multiplied. And actually every number will get multiplied twice. Okay, what's 4 times 10 times negative 1? Negative 40. What's negative 2 times 1 times 2? So plus negative 4. Okay, all these red ones I'm adding them together. Okay, and then 0 times anything? 0. Okay, the next ones will go from right to left. 4 times 10 times negative 1 gives me the negative 40. Then, like, I'm working like along those diagonals. Okay, now, and notice here I put minus Okay, I'll call these again. The negative 40, the negative 4, and the 0, those are my answers from the, I like to call them the left diagonals. Now I'm going to do minus the right diagonals. So I'm going from, starting up here. 0 times 10 times 2, 0. Okay, what is 4 times 1 times 6? Okay, 4 times 1 times 6 is 24. And then I'll do negative 2 times negative 3 times negative 1, negative 6. And then you say add, subtract. Negative 40 minus 4, or plus negative 4. Okay, and 24 minus 6. And then now you can just say, what's negative 44 minus 18?
Minus, is that a parentheses?
Where? Here?
Yeah.
Yes.
Yes.
Yes, it was a parentheses. Yes.
Okay. Because after that I asked if that was a 1.
It was a parentheses. Because what I'm saying is, this side right here, this side, the negative 40, the negative 4, and the 0, that represents like my left diagonals. My answers from the left diagonals, going from left to right. In parentheses, because I'm going to subtract the left minus the right, in the parentheses I put the answers from the right diagonals. The ones that are in white, that I went from right to left to get the numbers.
You don't do anything with the 10 and negative 3.
That's been the most common question I've been asked. But if you look in the 1, 2, 3, the fourth column, there's that negative 3. It got used twice. So that's the way, when I rewrote these, that will allow me to get all those numbers in twice. The 10, even though it doesn't look like it's used here, it is used in the second column twice. Yep. Okay. So we can find the area of a triangle with determinants using this formula. 1/2 the determinant times a matrix that is made 1 row of x's, 1 row of y's, 1 row of 1's. So there will be, it's a 3 by 3 matrix. It will be x's, y's, 1's. And it's always 1, 1, 1 on the bottom row.
X, Y.
Kind of weird that somebody came up with that, but yeah, they found that for me. It had to be 1's. Okay. So with that idea, you should be able to find the area of a triangle. Let's say FGH. That F is the coordinates negative 1, 4. G are the coordinates negative 2, 3, negative 3. And H is the coordinates 3, negative 2. Take a moment, find that area.
18.
Okay, so 17 should be your answer. That's it. And again, that's just giving you the area of a triangle, not very difficult. Any questions on that? All right, so that gets us to Cramer's rule.
Oh. Every time you say cramer, it reminds me of science.
To help you solve systems. Start off with this format. This is normally written in a format that would look like it's ready for elimination. So, say that you have like x and y equation equal to some number, another x and y equation equal to some number. So you want x's and y's on the same side. The a1, b1, c1 are just numbers. Okay, numbers in front of the x, numbers in front of the y equals answers. Another set of numbers in front of the x, another set of numbers in front of the y equals some answer. You're going to create 3 matrices based off your equation. The first one I'll call the coefficient matrix, and denote it with letter D. That's just basically the numbers in front of the x and y as a matrix, a 2 by 2 matrix. So that's where I got A1, B1, A2, B2. It's just the numbers in front of the x's and y's. Then you're going to make an X matrix. That's basically the same thing, but instead of the X coefficient, you're going to put the answers in place of the X. So C1, C2, B1, B2. And then you'll have a Y matrix, and that one's going to be the X numbers and the answers instead of the Y numbers. So A1, A2, the numbers that were in front of the X, and C1, C2, the answers, what they were equal to. Okay. Once you will take the determinant of each one of those matrices, and then your final answer for the system, for the equations. You know how last chapter test, we were always going x equals this, y equals that, or whatever. It's just this. For x, it's the determinant of the X matrix divided by the determinant of the D matrix. And Y is the determinant of the Y matrix divided by the determinant of the D matrix. Should have said C matrix, coefficient. That makes more sense. So here's our first example using this set of notes. Take negative x plus 3y is equal to 7. 2x plus 3y is equal to negative 7. Again, from this, you're going to make three matrices. The first one, your X matrix, is going to be what? I'm sorry, not your X matrix, your D matrix. Your first one, your D matrix, will have what numbers?
Negative 1, maybe. Right?
Negative 1, yeah, keep going.
Negative 1, 3, 2.
Correct. Negative 1, 3, 2, 3. There's your D matrix. Okay, your X matrix. Instead of having negative 1 and 2 in the first column, what are you going to put? 7 and negative 7. And then your Y matrix, instead of having 3, 3, you're going to put 7 and negative 7. Okay, notice. Basically, from the D matrix, we just changed a couple little ones, and then we were able to make that. Find the determinants of each one of those matrices. So on the calculator or whatever, find the determinants of each one of those matrices.
You divided x by the...
No, I will in a minute. But so to get the X answer, X is equal to 42 divided by negative 9. That's all it is. Take those two determinant answers. X is equal to 42 divided by negative 9, which probably in your calculator will give you something like negative 14 over 3. And then the Y answer is just negative 7 over negative 9, which is positive 7 over 9. And there you go.
What about...
So where I was like, I would say get started on it in class, is practice B, page 28, problems 1 through 12.